Namaskar. Welcome to the YouTube class of computer application on behalf of Southern School affiliated to CIC New Delhi. Today our lesson is to sort an array in ascending order using the technique of selection sort. This lesson is divided into 6 parts. At first I will tell you the definition of selection sort. Next you will be told why is it termed as selection sort. After that the algorithm, and then I will explain the logic or the algorithm. Next the implementation of the logic in program, and after that the execution of the program in BlueJ environment. The definition of selection sort is quite simple. It is a simple sorting technique which is used to arrange the elements of an array either in ascending order or in descending order by selecting a specific element from a set of data items. In case of arranging elements in ascending order, this technique repeatedly selects the next smallest element and then swaps it with a specific element in the array to put it in the perfect place. And in case of arranging elements in descending order, the technique of selection sort repeatedly selects the next largest element and then swaps it with a specific element in the array to put it in the perfect place. This is the reason why this special sorting technique is known as selection sort, because it works with the method of selecting elements. So now the algorithm to sort the elements of a single dimensional array using the technique of selection sort in ascending order, and the algorithm is quite simple. At first we need to find out the smallest element from the array, and then we have to exchange it with the element which is placed at 0th index in the given array. After that we will find out, means in the second step we will find out the next smallest element, means the second smallest element, and then we will exchange it with the element which is placed at first index. After that, means in the third step, we will find out the third smallest element, and then again we will swap it with the element which is placed at second index, and we will continue this process until the entire array is sorted. So this is the diagrammatic representation of an array, consists of 5 elements, you can see, and this is the Java statement to directly initialize the array to the array variable a. You can see this is the array variable of int type. So we have to sort the array in ascending order. So in ascending order, the smallest element should be placed at first and the largest element should be placed at the end. So you can see that this array is unsorted. Here 45, then 7, then 32. So this is unsorted. It is sorted neither in ascending order nor in descending order. So it is unsorted. So we have to sort this array, suppose in ascending order. So let's start the process. As we are sorting the array elements in ascending order, that's why in the first pass we need to find out the smallest element. So for this we need to consider the element a0 as smallest. So I am taking a variable sm for storing the smallest element sm. So sm equals to a of 0, which is 45, and also we have to note down the index of this sm. So as of now the index is, I'm taking a variable in for that index, in equals to 0, because it is a of 0, that's why the index is 0. So now rest of the elements will be compared with this sm. If any of those elements is smaller than sm, then the value of sm will be changed. So at first a of 1 will come, a of 1 which is 7, and here SM is actually 45. So we will compare. Is A1 smaller than SM? Obviously 7 is smaller than 45. So that's why the condition is satisfied. So the value of SM will be changed. So I am writing the new value of SM, that is SM equals to A of 1, that is 7. So the index will also be changed of the SM, that is IN equals to now 1. Okay, so next element will come, that is A of 2. A of 2 means 32, and our new SM is 7. So 32 is less than 7? No. That's why the value of SM will remain unchanged. Now the next element A of 3 will come. So A of 3, which is 83, and SM is 7. So 83 less than 7? No. So the value of SM will remain unchanged. Now the last element will come, that is A of 4, and SM is 7. A of 4 is 56. So 56 is less than 7? No. So the value of SM will remain unchanged. So actually we consider an element A of 0, which is to be the smallest, but actually the smallest element is your A of 1. You can see A of 1. So the element that was considered was A of 0 in the first pass, but actually the smallest element is A of 1. So they will be interchanged. You can see. So here 45 will go to index number 1 and 7 will go to index number 0. So the resultant array will be I am drawing the array. There are 5 blocks: 0, 1, 2, 3, 4. So 7 here, 45 here, and rest of the elements will be as it is. So the noticeable thing is that how many comparisons are performed in the first pass. Let's see. Here 1, 2, 3 and 4. So remember, there are 5 elements and 4 comparisons performed in the first pass. And how many swapping? Swapping is only 1, that is A of 0 and A of 1 both are exchanged. So swapping, number of swapping is 1. So we have got the smallest element after the end of the first pass. You can see that 7 is the smallest element here. So this is the array we have got after the end of the first pass. So now you can see that here 7 is fixed. So we already got the smallest element. Now in second pass we need to get the second smallest element, as we are arranging in ascending order. So again I am taking the variable SM to consider element that is placed at index number 1. So Sm equals to A of 1, which is 45 I'm writing, and also the index of A of 1 is 1. So I'm marking this one. So these are the elements which are placed at index number 2, 3 and 4 will come here for comparison. So at first this one, A of 2. So at first A of 2 will come. So A of 2, which is 32, and Sm, which is 45. So what is the relation between A of 2 and Sm? You can see that 32 is less than 45. So 32 is less than 45, it is satisfied. So the value of Sm will be changed. So Sm equals to A of 2, which is 32, and the index is 2 now. The index of Sm is 2 now. So the next element will come, which is A of 3. A of 3 means 83, and Sm is now 32. So relation between 83 and 32, 83 is less than 32, obviously not, so the value of Sm will remain unchanged. So now the next element will come, that is A of 4. A of 4 means 56, as you can see here, 56. So the value of A of 4 is 56, and Sm, which is 32. So 56 is less than 32, obviously not, so the value of Sm will remain unchanged. So the final value of Sm is 32 in this iteration, in the second pass. So we considered A of 1, and actually the second smallest element is A of 2. So they will be exchanged. So let's do this in the diagram also. 45, which is placed at index number 1, will move to index number 2, and 32, which is actually the second smallest element, will move to index number 1. So the resultant array will be there are 5 blocks, 0, 1, 2, 3, 4. So now the first element was already fixed, that is 7. Now 32 and 45 exchanged. So 32 here, 45 here, and rest of the elements 83, 56 will be as it is, and 32 is fixed, that is the second smallest element. So now let's see how many comparisons are performed in this iteration. You can see 1, 2 and 3. So total number of comparisons I am writing is 3, and number of swapping is only 1, like first iteration. So swapping, number of swapping is 1. We are now in third pass. You can see 7 and 32 already fixed, so the smallest element and the second smallest element we have already got. Now we have to get the third smallest element. So now we will consider A of 2. So Sm equals to A of 2 now, I'm also writing the value, that is 45, and the index is 2. I'm marking this one. So the element that will come for comparison at first, that is a of 3. So a of 3, the value is 83, and here sm, the value is 45. So what is the relation between a of 3 and sm? A of 3 is less than sm? Obviously not. So the value of sm will remain unchanged. Now the next element will come a of 4. Now a of 4 means 56. You can see 56, 56, and sm is 45. So 56 is less than 45? No. So the value of sm will remain unchanged. Now no other elements. So we consider a of 2 to select the third smallest element, and in the third pass we got the third smallest element, which is also a of 2. So a of 2 will be swapped with a of 2. So a of 2 will be swapped with a of 2 only. That means a of 2, or the third smallest element, is actually in the correct place. So let's do it in diagram also. So 45 is swapped with 45 only. So now the resultant array is, let's draw it. There are 5 blocks, 0, 1, 2, 3, 4. So the elements will be as it is: 7, 32, 45, 83, 56. 7, 32, 45, 83 and 56. So after the end of the third pass, 7, 32 and 45, these elements are fixed. So now let's see the total number of comparisons performed in the third pass. You can see 1 and 2. So the total number of comparisons is 2, and the total number of swapping is only 1. So swapping, the total number of swapping is 1. So after the end of the third pass, we have got the smallest element, the second smallest element, and also the third smallest element. So we need to find out the next smallest element. So again, take the variable sm and consider the next element, that is a of 3. The value is 83, and the index of a of 3 is obviously 3. So I'm marking this one, and the element, the only element that is remained to be compared is 56, that is a of 4. So a of 4, which is 56, will be compared with the sm, which is 83. So the relation 56 is smaller than 83. Condition is satisfied. So the value of sm will be changed. So sm is now a of 4 means 56, and the index will be now 4. So no other comparison left. So the element that was considered was a of 3, and actually the next smallest element is a of 4. So they will be interchanged. Let's do this in the diagram also. 83 will move to index number 4, and 56 will move to index number 3. So the resultant array will be there are 5 blocks 0 1 2 3 4. So you can see 7 32 45, they are already fixed. And now we got the next smallest element as 56. So I will write here 56 and it is now fixed. And the next one is 83, as no other element is left, that's why 83 is also fixed. So the number of comparisons we will see now. You can see only 1. So number of comparisons I am writing only 1, and number of swappings as usual 1. So in every iteration the total number of swapping is 1. So in 4 passes total 4 swapping. So now the operation is completed. So I hope you understood the logic properly, and now the implementation of the logic in Java program. So how to implement it? So we have to at first look at some important things. You can see the first pass, how many comparisons perform? 4, and only 1 swapping. In the second pass, 3 comparison, 1 swapping. Third pass, 2 comparison, 1 swapping. Fourth pass, only 1 comparison and only 1 swapping. So you can see that these are actually varying. So after every pass the number of comparison is getting decremented by 1. So these numbers are actually varying. So the comparisons must be performed inside a nested loop. And you can see that the first pass, second pass, third pass, fourth pass. So these passes will be controlled by the outer loop. And here the number of swapping is also remains constant, that is only 1. So this swapping will also be conducted in the outer loop, but you can see that after the comparison. Why? Because you can see here the first the element that are that we are considering here, you can see sm a of 0. Okay, so only one time we are considering in every pass. In the second pass also only one time. In the third pass also only one time, and in the fourth pass also only one time. So after that you can see in the first pass the comparisons are performed. So this is the start of the nested loop. So these are actually happening inside the nested loop. 1 2 3 4 4 comparisons are being performed inside the nested loop, and when the comparisons are finished then the swapping is performed. So obviously the consideration, element consideration will be just before the nested loop, means just after the start of the outer loop, and then the nested loop begins. You can see I am showing in the second pass also here. So the comparison begins, that means that this is the start of the nested loop, and when the nested loop ends then the swapping is performed. In the third pass also the same thing, the comparison performed and then the swapping performed. In the fourth pass also element consideration, comparison, that is inside the nested loop, and then swapping. Now let's write the code for the outer loop. For I am taking loop control variable to control the number of passes as I equals to 0, then I less than n minus 1, and here I plus plus because it is forward loop. Now why I less than n minus 1? Let's analyze it. Total number of elements n equals to 5 and we need 4 passes. The initial value of I is 0, so we need the last value of I as 3 because 0, 1, 2 and 3. So obviously we will get 3 if I write I less than 5 minus 1, that means I less than 4. So I will get the last value as 3. So now let's write the code for the element consideration. So we took the variable sm for that. So I am writing here sm equals to a of I. Here a is the array variable. And I am also writing the index in the variable in. So index is I. As you can see here, a of I is the element, so index will be obviously I. Now let's write the code for the nested loop. So for j equals to, what will be j equals to? Let's analyze. You can see that the element that we are considering a of 0 and the first element that is coming for comparison is a of 1. This is in the first pass. In the second pass, we are considering element a of 1, that is the index 1, and the element that is coming for comparison at first, it is a of 2. In third pass, the element that we have considered is a of 2 and the element that is coming for comparison at first is a of 3. So every time the element which we are considering, the next element is coming for comparison. That's why we can write here j equals to I plus 1, because the index I is getting considered and we will get the first element to be considered for comparison is I plus 1. So I will write here j equals to I plus 1 and here j less than. Now what I will write here? Let's analyze. In the first pass, the last element that is coming for comparison is a of 4. In the second pass also, the last element that is coming for comparison is a of 4. And in the third pass also, the last element that is coming for comparison is a of 4. In fourth pass also, the last element that is coming for comparison is a of 4. So every time the last element that is coming for comparison is a of 4, which is the last element, of our array that consists of 5 elements. So if I write here j less than n, then j less than n means 5, so j will get the value 4 at the last iteration of the inner loop. So the code will be like this: j less than n and here j plus plus, because it is also a forward loop. Now inside the nested loop, comparison will be performed. So every time the comparison is being performed between the element that is being considered and the elements that are coming one by one. So here we will write if a of j, I will write here j because j is the array index here, not I. I is controlling the number of passes and j is controlling the array index. So if a of j less than Sm, if A of j is less than Sm, then only the value of Sm is changed. So I will write here Sm equals to, obviously will be A of j. So I am writing here A of j, and the index will also be changed. Here in equals to will be j. So this is the end of the if block, and there is nothing to do inside the nested for. So nested for loop is also closed. And now the swapping will be performed. So swapping will be performed inside the outer loop, and you can see that the outer loop is still not closed. So let's perform. So perform the swapping. Here I am performing the swapping using third variable. So I am taking a variable t. So t equals to, the element that was considered was a of I. So I am writing here t equals to a of I, and then a of I equals to a of in. And now a of in equals to t. So now the swapping is done, and the outer for loop is now closed. So the variable that are used in this code segment, you can see I is the loop control variable for outer loop, and then Sm, which is used for the element to be considered at the start of every pass, and then in, which is used to store the index of the element to be considered, and next j, which is the loop control variable for the inner loop, and at last the t, which is used as the third variable in executing the swapping. Three important theoretical questions that you may face in the examination regarding selection sort is: number 1, total number of passes; number 2, total number of comparisons; and total number of swappings. So let's see. You can see here, this is our result of analysis. First pass 4 comparison in case of 5 elements, remember. First pass 4 comparisons, only 1 swapping. Second pass 3 comparisons, 1 swapping. Third pass 2 comparison, 1 swapping. And fourth pass 1 comparison and 1 swapping. So let me tell about the passes at first. So you can see that in case of 5 elements we require 4 passes. So in case of n number of elements we will require how many passes? In case of an array that consists of n elements, number of passes will be n minus 1, because in case of 5 elements we require 4 passes. So in case of 10 elements you will require 9 passes. In case of 15 elements you need 14 passes, like that. Now come to the comparison, that is total number of comparisons. To solve this one, before solving this one, I want to tell you one formula regarding mathematics, that the sum of all the natural numbers from 1 to n, sum of all the natural numbers from 1 to n is n into n plus 1 by 2. That is the formula, where n is the last natural number and 1 is the first natural number. So in our analysis you can see First pass 4 comparison, then 3, then 2, then 1. So actually in case of 5 elements, we are getting 4 comparison at first in first pass, then 1 comparison decremented, then 1 comparison decremented, so it is ending at 1. So in case of 5 elements, 4 comparison at first and it is ending at 1. So sum of all the natural numbers from 4 to 1, or you can also say 1 to 4. So in case of n elements, you have in case of first pass you will get n minus 1 comparison, and then you will get n minus 2 comparison, then you will get n minus 3 comparison, dot dot dot, at last you will get only 1 comparison. So here you need to calculate the sum of all the natural numbers from n minus 1 in case of an array that consists of n elements. I am writing n plus 1 plus n minus 2 plus n minus 3 plus dot 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 plus 1. So actually the addition will be the sum of all the natural numbers from n minus 1 to 1, or also you can say 1 to n minus 1. So according to this formula, this is the natural numbers from sum of natural numbers from 1 to n, and this is sum of all the natural numbers from 1 to n minus 1. So I can write here n minus 1 into n minus 1 plus 1 divided by 2, that is n minus 1 into n by 2. So this will be the formula. So you can see in case of 5 elements, 4 plus 3 plus 2 plus 1, 4 plus 3 7 plus 2 9 plus 1, total 10 comparisons are there. So let's put according to this formula here. According to our example, n equals to 5. So what is the total number of comparison? According to this formula, n minus 1 into n by 2. So n minus 1 means 4 into n means 5 divided by 2. So you can see that 5 2s are 10. So total 10 comparison. You can see 4 plus 3 plus 2 plus 1, 4 plus 3 7 plus 2 9 plus 1 10. So total 10 comparison. So in case of n number of elements, you can directly put the value of n here in this formula, and you can easily get your result for this question, total number of comparisons. Now total number of swappings. You can see in every pass only one swapping. First pass 1, then second also 1, third also 1, fourth also 1. So total number of swapping is equal to the total number of passes, and you already know that the total number of passes in case of an array that consists of n elements is n minus 1. So also the total number of swapping will be n minus 1. Total number of swappings. Okay, and these values will be same for the technique of selection sort in ascending order as well as in descending order. So we will now execute the program in Java environment using BlueJ IDE. So you can see that I have already written the program with the class name selection sort. So I am opening it. Yes, you can see that public class selection sort. The selection sort is the name of the class, and then the main function has been used. So here declaring the variables. So here I have used the array variable a, and I have initialized that array variable with the same elements that I used in while explaining the logic of that program. And after that you can see that n equals to 0. Here n, the variable is used to find out the length of the array. I is the loop control variable, j is also the loop control variable, you already know. Sm is the variable to find out the smallest element, in is the variable to find out the index of the smallest element, and t is the temporary variable which is used as a third variable for the purpose of swapping. And here n equals to a dot length, this is the statement to find out the length of the array considered. And after that I have used the logic for the technique of selection sort. You can see the comment sorting using the technique of selection sort. So here I equals to 0, I less than n minus 1, I plus plus. You already know that, I have already explained. Sm equals to a of I, the element has been considered, and ultimately the smallest element is found here inside the nested loop. And after the end of the nested loop, the element which was considered to be the smallest and the actual smallest element, that is a of in, is exchanged. Yes, they are exchanged. And after that finally we will display the sorted array. So this is the code. System.out.println, the array after sorting in ascending order, because we are sorting the array in ascending order. I am giving you the reminder once again. And then one blank println statement to keep a distance between this statement and the output. And this is the code for I equals to 0, I less than n, I plus plus, system.out.print a of I plus space. This line will print all the elements of the sorted array in the same line, and one space also will be printed in between two consecutive elements of the array. So I will now compile. You can see here this is the compile option, so I am compiling, and here you can see class compiled, no syntax error, so you are allowed to run the program. So just close this window and you can see that selection sort, that is now totally compiled, so I am running it. Click on OK. Yes, you can see the array after sorting in ascending order 7, 32, 45, 56, 83. So now the difference between bubble sort and selection sort. So here I have made a difference table. On the left hand side bubble sort and on the right hand side selection sort. So the first point, it compares two adjacent or consecutive elements and swaps them if they are in imperfect order. This is bubble sort. But in case of selection sort, you have noticed that it selects the next smallest element in case of arranging elements in ascending order, or next largest element in case of arranging in descending order repeatedly, and swaps it with a specific element to put it in the perfect place. This is point number 1. Now point number 2. Bubble sort applies the method of exchanging elements, but selection sort applies the method of selecting elements. Point number 3. Bubble sort requires more swappings as compared to the selection sort, but selection sort requires less number of swappings as compared to the bubble sort. You have noticed in the analysis of the logic that in one pass only one swapping. That's why it requires less number of swappings as compared to the bubble sort. Now the last point, the elements are arranged from the last index of the arrays. You know that. And in case of selection sort, the elements are arranged from the 0th index, which is the first index of arrays. Hopefully I have managed myself to clarify your doubts regarding selection shot as well as the difference between bubble shot and selection shot. So that's all for now. We'll see you in the next class. Until then, stay at home, stay safe, and goodbye.